Welcome. Today we're going to look at solving trigonometric equations. This is chapter 5.3 in your text. So let's go ahead and take our notes out and we'll get going. During this video you will also need your Trig Identities sheet or handout, and you also need your unit circles. So let's get all our materials out and then we'll get going. Our objective in this video will be that students will solve equations with two or more trigonometric functions using identities and factoring techniques. And remember, when we say factoring techniques, we're really looking at our zero product property concept. Okay, let's go ahead and jump into our problem. So let's go ahead and write the problem down. I have 2 sine squared x plus 3 cosine of x minus 3 is equal to 0. That's 2 sine squared x plus 3 cosine of x minus 3 is equal to 0. And it appears I'm looking to solve it, and I don't have a specified interval, so I need my general solutions. Now, looking at this problem, a few things I observe is it's got 3 terms, so it's a trinomial. The degree is 2, so it's a quadratic, so I'm going to look at using factoring techniques most likely. And I also notice I have both sine and cosine, 2 different trig functions. Alright, so in order to solve this, I'm thinking my zero product property, it's already set equal to 0, so I'm going to need to factor the left side. I can't factor as long as I have sines and cosines. I need to somehow rewrite this in terms of sine or in terms of cosine. So I'm going to look on my identity sheet and see what can I do to change a sine into a cosine or cosine into sine. So go ahead and pause the video, take a look at your sheet and see what you can come up with. Okay, when I looked at my trig identity sheet, I noticed that I have sine squared x plus cosine squared x is equal to 1. I'm looking at my Pythagorean identities, and a manipulation of that would be that cosine squared x is equal to 1 minus sine squared x, or sine squared x is equal to 1 minus cosine squared x. So what I'm going to do is use the second one, and I'm going to replace my sine squared x with 1 minus cosine squared x. And again, that's manipulation of the Pythagorean identity. And in doing so, I can write my equation in terms of all cosines, which means it can be factored. So, after replacing sine squared x with 1 minus cosine squared x because it's equivalent, I also have to remember that I have to multiply through by the 2, so this becomes 2 minus 2 times cosine squared x plus 3 cosine of x minus 3 is equal to 0. So, you have to remember to simplify and have to remember the distributive property. Okay, so now I'm going to simplify even further. I notice I have some like terms. I have the 2 and the negative 3. So I'm going to rewrite this as negative 2 cosine squared x plus 3 cosine x. That doesn't change. Combining the 2 and the negative 3 leaves me negative 1, and that's all equal to 0. Now I've rewritten the left side in terms of cosine, and now I'm set up to start my factoring. Okay, let's go ahead and factor this. Now remember, if you have a way you like to factor, go ahead and use it. I'm going to go ahead and use the way I know. So I'm going to put my x over here. I'm going to multiply the leading term coefficient by the constant. So negative 2 times a negative 1 is a positive 2. I'm going to find factors of the positive 2 that add up to the middle term coefficient of 3. And those factors are positive 1 and positive 2. I also have to remember to divide through by the leading term coefficient of negative 2 and simplify where I can. Now my first side, negative 1/2, can't be simplified. However, my other side of 2 over negative 2 can be simplified. And I'm out of room, so I'm going to go ahead and write it down here. That would simplify to negative 1. Okay, Let's go ahead and write our factors. So my parenthesis, I would write, because it's cosine squared, this is cosine x, and close parenthesis, and this one would be cosine x. Cosine x times cosine x is cosine squared x. And I'm getting tight on space, so I'm just going to box out my side work. I'm going to take the negative 1/2, write it here, and the negative 1, write it in the other factor. Now to fully factor, I remember I can't have a denominator, so I'm going to move the 2 in front of the cosine. This is 2 cosine of x minus 1, and this is cosine of x minus 1 is equal to 0. All right, now we're in the form of the zero product property. I have a times b is equal to 0, or this, the left side, the two expressions being multiplied together equals 0. So all I have to do is set them both equal to 0 and solve. So this becomes 2 cosine x minus 1. Let's set it equal to 0 and solve this. So if I add 1 to both sides, I get 2 cosine x is equal to positive 1. Divide through by 2. I get cosine x is equal to 1/2. And again, I just added 1 and divided by 2. All right, now we're ready to go search for the angle for the first expression. The second expression, I have cosine x minus 1. I'm going to set it equal to 0. And I know I'm getting a little tight on room in here. So let me actually just fix that. Make it a little more readable. This becomes cosine x minus 1 is equal to 0. I'm going to add 1 to both sides. In my second expression, I'm looking for all the angles that I take the cosine of, and I get positive 1. Now let's go ahead and pull out our unit circle and find these angles. I've got my unit circle out, and now I'm going to look for the angles. I'll start with where cosine x is equal to positive 1. Remember, cosine is our x value. Where is x positive 1? Well, that occurs at 0 and the only spot. So here's one of those rare occasions where there's only one angle, and that would be when x is equal to 0. Whereas cosine 1/2, again, cosine is my x, so it looks like positive 1/2 lies at pi over 3. And down at 5 pi over 3. So it appears there are 3 angles that will make this equation true. 0, pi over 3, and 5 pi over 3. Lastly, we just need to write out our solutions. So we said x is equal to 0. We said x is equal to pi over 3, and x is equal to 5 pi over 3. Now, if I was given a specified interval, say, or using the most common one we see is from 0 to 2 pi, those would be our 3 answers. But we're not given a specified interval between 0 and 2 pi. We're looking for the general solution. So therefore, I have to add on my plus. Now remember, the period of sine and cosine are 2 pi. So I'm adding on plus 2 pi n, plus 2 pi n, and 2 pi n. So one more time, if you're looking for just the solutions between 0 and 2 pi, we would simply look at our original answers that we found, which were these guys. But this one didn't give us an interval, so again, we have to add on the 2 pi n. So I'm going to go ahead and take this back off. And these will be our answers. Okay, if you have any questions, remember, write them down and ask me during class. Other than that, thank you for listening.